PixArt, a fast training of diffusion transformer for photorealistic text-to-image synthesis. The most advanced text-to-image T2I models require significant training costs, for example millions of GPU hours, seriously hindering the fundamental innovation for the AIGC community while increasing CO2 emissions. This paper introduces PixArt Alpha, a transformer-based T2Y diffusion model whose image generation quality is competitive with state-of-the-art image generators, for example Imagen, SDXL, and even Midjourney, reaching near-commercial application standards. Additionally, it supports high-resolution image synthesis up to 1024px resolution with low training cost, as shown in Figure 1 and 2. To achieve this goal, 3 core designs are proposed. 1. Training strategy decomposition. We devise 3 distinct training steps that separately optimize pixel dependency, text-image alignment, and image aesthetic quality. 2. Efficient T2I transformer. We incorporate cross-attention modules into Diffusion transformer, DIT, to inject text conditions and streamline the computation-intensive class condition branch. 3. High informative data. We emphasize the significance of concept density in text-image pairs and leverage a large vision language model to auto-label dense pseudo-captions to assist text-image alignment learning. As a result, PixArt Alpha's training speed markedly surpasses existing large-scale T2I models. For example, PixArt Alpha only takes 10.8% of Stable Diffusion v1. 5's training time, 675 versus 6,250, A100 GPU days, saving nearly $300,000, $26,000 versus $320,000, and reducing 90% CO2 emissions. Moreover, compared with a larger SOTA model, Raphael, our training cost is merely 1%. Extensive experiments demonstrate that PixArt Alpha excels in image quality, artistry, and semantic control. We hope PixArt Alpha will provide new insights to the AIGC community and startups to accelerate building their own high-quality yet low-cost generative models from scratch. Enable language models to implicitly learn self-improvement from data. Large language models have demonstrated remarkable capabilities in open-ended text generation tasks. However, the inherent open-ended nature of these tasks implies that there is always room for improvement in the quality of model responses. To address this challenge, various approaches have been proposed to enhance the performance of LLMs. There has been a growing focus on enabling LLMs to self-improve their response quality, thereby reducing the reliance on extensive human annotation efforts for collecting diverse and high-quality training data. Recently, prompting-based methods have been widely explored among self-improvement methods owing to their effectiveness, efficiency, and convenience. However, those methods usually require explicitly and thoroughly written rubrics as inputs to LLMs. It is expensive and challenging to manually derive and provide all necessary rubrics with a real-world complex goal for improvement, for example, being more helpful and less harmful. To this end, we propose an implicit self-improvement (PIT) framework that implicitly learns the improvement goal from human preference data. PIT only requires preference data that are used to train reward models without extra human efforts. Specifically, we reformulate the training objective of reinforcement learning from human feedback, RLHF. Instead of maximizing response quality for a given input, we maximize the quality gap of the response conditioned on a reference response. In this way, PIT is implicitly trained with the improvement goal of better aligning with human preferences. Experiments on 2 real-world datasets and 1 synthetic dataset show that our method significantly outperforms prompting-based methods. Conditional diffusion distillation. Generative diffusion models provide strong priors for text-to-image generation and thereby serve as a foundation for conditional generation tasks such as image editing, restoration, and super resolution. However, one major limitation of diffusion models is their slow sampling time. To address this challenge, we present a novel conditional distillation method designed to supplement the diffusion priors with the help of image conditions. allowing for conditional sampling with very few steps. We directly distill the unconditional pre-training in a single stage through joint learning, largely simplifying the previous two-stage procedures that involve both distillation and conditional fine-tuning separately. Furthermore, our method enables a new parameter-efficient distillation mechanism that distills each task with only a small number of additional parameters, combined with the shared frozen unconditional backbone. Experiments across multiple tasks, including super resolution, image editing, and depth-to-image generation, demonstrate that our method outperforms existing distillation techniques for the same sampling time. Notably, our method is the first distillation strategy that can match the performance of the much slower fine-tuned conditional diffusion models.